Hello everyone, my name is Victor Sapiain. In this video, I'm going to explain the CI/CD pipeline architecture I created for my Java application, Password Checker. The goal of this pipeline is to automate the full software delivery lifecycle from pulling code all the way to developing a Docker image using multiple Java versions and industry standard tools. The main tools and technology used in this pipeline were Jenkins, GitHub, Maven, SonarQube, Docker, and Docker Hub. So first I'm going to explain my code that I developed. So I'm going to show you my code through GitHub. So it's a pretty basic code. As you can see, it's only about 7 lines. The first line is package.com.example, which is your namespace, which helps organize the code. Public class password validator, that is to define a class, which is password validator. The public boolean is strong password. String password, that is a public method, and it takes the string password as an input and returns a boolean. It returns true if the password is strong and false if the password is not strong enough. And it returns false if you don't put anything in, right? If the characters are less than 8, you get a false. So the next part of my code is the JUnit test. So as I said, package.com.example, that is the namespace. Next line is import org.junit.jupyter.api test. This imports the JUnit 5 annotation to mark a method as a test case. The next line right here that I'm highlighting imports common assertion methods like assert true and assert false, which I use later in my code right here where I highlighted. The public class right here is password validator test, which creates or right here, this line right here creates an instance for my validator class. So once again, the purpose of this code is to determine if the password input is strong enough. If it's only, let's say, over 8 characters, it's 10 characters, then it should return true. If it is less than 10, or excuse me, less than 8, and let's say, for example, you put a password that's only 5 characters, it returns a false. And if you don't put anything in at all, it should return a false as well. So that being said, that is my code. I then push this code onto my GitHub repository, which I named Password Checker JUnit. Or excuse me, yeah, Password Checker JUnit. So now I'm gonna talk a little more about my pipeline, which is saved under Jenkins file. So here is my Jenkins pipeline right over here. So first things first, I talk about the environment it runs, right? So as you can see, I use Docker image, Docker tag, SonarQube URL, SonarQube. This is the name of my SonarQube server. This right here is the URL that my SonarQube is running on. Yes, so this helps with centralizing configurations which make them easier to reuse in later stages. The next stage, I have a couple of stages. So my main stages are checkout code, build, test, SonarQube connectivity check, SonarQube analysis, build Docker image, and push to Docker Hub. Those are my main stages. I'm going to be explaining each stage individually. So the first stage is the checkout code right here. This stage is called checkout code. I have just highlighted it. So the purpose of this stage is it pulls code from my GitHub repository using a secure personal access token stored in Jenkins, which I produced myself, and it's targeting the main branch specifically, as you can see right here, right there. All right. So the next stage is the build stage, which is right here. I'm highlighting it right now. So this code is compiled using Java 17 inside a Docker container. So this is right here, the Docker container, which is CIMG slash OpenJDK 17.0. I run mvn clean package to generate the jar file and ensures the build happens in a consistent environment. It runs inside a Docker container with Java 17, and the clean package script right here, command compiles the app and packages into a jar file, as I stated before, which then moves on to the next stage of my pipeline, which is the testing stage. In the testing stage, the same base Docker image is used, but the idea is to test the application using Java 11 compatibility to ensure backward compatibility. While the container runs Java 17, the test logic and dependencies are all valid for Java 11 and validated using JUnit 5. Right. So later I'll show my POM XML file that I use the Maven Surefire plugin to ensure that the JUnit 5 tests run smoothly. So still inside the same Java 17 container, I'm executing the unit test, which is the Maven test right here. And while Java 17 is being used, JUnit 5 tests are backward compatible with Java 11. The next stage is the SonarQube connectivity check. This stage right here is actually I am gonna talk about all of these right here that are highlighted. So these are two stages that I jumbled together. So with this stage, it is the helps with running SonarQube static code analysis. So the first part of it is the SonarQube connectivity test right here. It's just a debug stage to make sure that Jenkins can reach the SonarQube server before analysis. I use it just to debug Docker network or service name issues. So if anything is going wrong, I can check what happened. So once that passes, it moves on to the next stage with SonarQube analysis, which once again runs the SonarQube static code analysis. And with the SonarQube env right here that I just highlighted, it injects SonarQube server settings from Jenkins global configurations. And I securely pass the authentication token using with credential. So right here is my SonarQube token that I developed on SonarQube and Jenkins. So once that stage is complete, it moves on to the next stage, which is build Docker image. So once the code is clean and tested, Jenkins uses a Docker file to package the application inside a Docker container. This includes installing Maven, copying the code, building it again and inside the image, and defining the command to run the app. It uses my Docker file to build an image tagged Victor Sapien password checker latest. So I could show you that right now. So here's the Docker file right here. I'll talk more about this later. So moving on to the final stage, which is push to Docker Hub. So finally, the pipeline authenticates with Docker Hub and pushes the image tagged as Victor Sapien password checker latest. It just makes it easier to pull and run the image from any system or cloud service. So once again, it pushes the image to Docker Hub using my secure Jenkins credentials, which will now lets me have a reusable image ready for deployment. So that is my pipeline that I run. And before I show you how it runs on Jenkins, I just want to go a little bit over my pom.xml file. So here is my pom.xml file. So this pom XML file just configures Java 17 for compilation, JUnit testing 5 for testing. It has the SonarQube Maven plugin for analysis, and it has other Maven plugins for compiling and running tests. So right here, this part of my pom.xml file, it just identifies my project uniquely. Yeah, so that just basically identifies my project. The next part is the properties. So it just sets Java 17 as a target for compilation. The SonarQube host is pointed to the Docker bridge IP. This ensures connectivity from inside the containers. The next part of my pom.xml file are the dependencies. So all this does is pulls in JUnit 5 for unit testing. So as it says right here, JUnit 5 dependency, right? It pulls in JUnit 5 for unit testing. So the next part of this file are my compiler plugins right here. So all this does is just the Maven compiler plugin to set Java 17. It just compiles Java code using Java 17. The next plugin is the Maven Surefire plugin, which basically just runs my unit test using JUnit 5. And the final plugin is the SonarQube Maven plugin with version 4.9.0.2856. So this just enables the code quality scanning for Maven CLI. So this is my pipeline, my pom.xml file, my Docker file, my my code, and my JUnit test code. So for this project, I had to create a Docker bridge network called CI network, so that all the containers, Jenkins, SonarQube, and my Maven builds could communicate by container names rather than IPs. So it allowed the Docker containers to basically talk to each other. It allowed Jenkins to access SonarQube 9000 on my URL. It allowed Maven containers to ping SonarQube or Jenkins, and it allowed containers to share the same virtual LAN. I used containers for Jenkins and SonarQube. with the help of CI network. And besides that, I use 3 different separate Java containers. I use 3 separate Java containers in the pipeline. As I showed you, the first one is in my build stage, second one's in my test stage, and my third one's in my SonarQube analysis stage. So the first one is the build. So I use Java 17 to compile the code. In the test stage, I used the same image, but I was able to make it compatible with Java 11 to simulate an environment, the same environment. And for the SonarQube analysis, I used Maven and Tamarin JDK inside the same network. And this basically could be swapped with Java 8 in order to enforce compatibility. So, just a quick summary. Jenkins, I basically used it for CI orchestration. SonarQube, I use for code quality analysis. My build stage, I use to compile Java 17 code. My test stage, which could be used with Java 11, used to run unit tests. SonarQube analysis was used with Maven and SonarQube. Final app image was a custom image to run the app, and my network was used with CI network in order to connect all the containers together. So now I'm going to show you how it runs on my Jenkins. As you can see, I've already had some successful runs. It did take me 110 tries to get to this point. So now I'm going to build it, and I will show you how it works. So the first test for the declarative checkout SCM was passed. The checkout code stage was passed. It is now on the build test. The build test has been passed. Moves on to the next stage, which is the test stage. This test stage has been passed. Now moves on to SonarQube connectivity check. Make sure everything's running correctly. There you go. It has been passed. Now moves on to the SonarQube analysis stage. SonarQube analysis stage has been passed. Now it moves on to the next stage, which is the build Docker image. The build Docker image stage has been passed and now moves on to the final stage of the pipeline, which is push to Docker Hub. And the push to Docker Hub stage has been completed. So as you can see, each stage of my Jenkins pipeline has been successful. And to make sure it moves on to my Docker home, here is my Docker. And right here is my tag. This is what has been pushed. As you can see, has been pushed 1 minute ago. That is what was just ran on my Jenkins pipeline. So that just shows that my pipeline has been successful. So that concludes my Jenkins pipeline project. I hope you enjoyed. Thank you very much.